Hey grade 12s, today we're going to take a look at graphing sinusoidal functions. In other words, we're given the equation and we need to graph the function. Now, the beginning of this lesson looks familiar, and it is, because I want to really recap and highlight the characteristics of the sine and cosine graph so that we have them, so when we start graphing this thing, we know what the hell we're doing, okay? Alright. So let's take a look at the sine curve first. The sine curve. Now again, let's go through it step by step. Okay? There is the vertical axis right here. Okay? This is the vertical axis. Alright? Now, at the standard sine x graph, when we were looking at that graph, it's going to start on that vertical axis. It's going to go up to the minimum. The minimum is 1/4 of the way through the graph. Halfway through the graph, it comes back down to pi, to 0, or to the axis level if it's not at 0. Then it comes down to the minimum 3/4 of the way through the journey. And all the way through the journey, it comes back up to that axis. That is what the sine x curve looks like, okay? And the cosine curve, as we said yesterday, is just a horizontal translation of the sine curve. And it starts at the top, it goes down to the vertical middle 1/4 of the way through the journey, it goes down to the minimum halfway through the journey, back up to the vertical middle 3/4 of the way through the journey, and back up to the top at the end of the journey. Okay? Alright. So, when we're looking at a graph of a sinusoidal function, it can be posed at us at two different ways. It can be posed at us at a graph this function on this domain, in other words, graph it from 0 to 2 pi, regardless if there's 1 period, half a period, or 3 periods in that given domain, or it could be graph at least 1 period of the sine function. Okay? So, again, as a review, we have the parameters A, B, C, and D. And again, A is the amplitude, B is the period, B influences the period, it's not the period. C will shift the graph left or right depending on what C is, and D will shift the graph up or down, and it's also the median line or the vertical middle. The period of sine x or cos x, unless altered, are 2 pi, and the period of any sinusoidal function is given as 2 pi over b, whatever b is. So let's get right down to business here. Let's graph at least one period of 10 sine x plus 4. So really only A and D are at play here. So I'm going to go ahead and make my scale here. I'm going to call this 2 pi over here. I don't even know how many things I got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18. Is that right? 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, if it's 18, that's fine. I don't like putting 2 pi there, though. I'm going to put 2 pi. I don't want the highlighter. I'm going to put 2 pi right here. And I'm going to put pi here. I'm going to put pi over 2 here. And I can put 3 pi over 2 right here. Now for the vertical scale, got 1, 2, 3, 4, 5, 6. So I'm going to go 4, 8, 12, -4, -8. -12. Then I plot my points. I am going to start in the vertical middle. Actually, because of that D value, I can't use that scale. My bad, I wasn't paying attention. I'm going to have to go to at least, okay, here's what we're going to do. We're going to go 5, 10, 15, negative 5, negative 10, negative 15. There we go. The vertical middle is 4 based on the D value. So what I'm going to do here is find out where 4 lives, approximately right here. Okay? And I'm going to put a point here. Quarter of the way through the journey, I'm going to go up here. Halfway through the journey, back down here. The minimum value will be 4 minus 10 is negative 6. So negative 6 is going to be right here. And then, oh, that needs a wee bit of correcting there. Has to be on the axis. Oh. Okay, let's go ahead and graph that. Okay. So we got something that looks like this, comes down like this, goes down to here, and comes back up there. Okay. There is our one period of 10 sine x plus 4. So we first located the vertical axis. We made sure our vertical scale accounted for the fact that the amplitude was 10. So that means that the graph went up 10 and down 10 from that axis. And then the period was a standard period of 2 pi. And there was no horizontal shift to worry about in this question. Okay? Pretty standard, easy graph compared to what they can get like. So now we have y equals cos 2x minus 3. Again, there's only two things to consider here. D is negative 3 and the 2x. So we'll consider the negative 3 part here first. So we're going to make one of these things at negative 3 here. So I put this at negative 3. All right. Because there's no number to represent A, the amplitude's 1, okay? That's fine. That's fine. So our scale here is going to look like this then. 0, 3, 6, negative 3, negative 6. Okay? Our B value here is 2. Now remember the period is equal to 2 pi over B, which is 2 pi over 2, which is pi. Okay? So the period is pi. So when I go ahead and I make my graph here, what I want to do is I want to put pi as my period over here. Okay? Because that's my whole period. And then halfway through the journey would be half of that, or pi over 2. Okay? 90 degrees. Half of that would be a quarter of pi, or pi over 4. So 1/4 pi is a quarter, so that means that 3/4 pi is 3/4 of the way through the journey. Okay? Now, as far as what the graph looks like, it is a cos graph. So it's going to start at the maximum. So the maximum would be like right here because the amplitude's only 1. It'll be on the axis right here. It'll be at the minimum at pi over 2. It'll be back on the axis 3/4 of the way through the journey. And it'll hit its maximum at pi. So we're going to get, and it doesn't, I mean, we're kind of limited by what our graph looks like here. But what it's really going to look like is something like this. And I kind of went a wee bit too far down there. So I'm going to try and correct it there. But that's basically what we're going to get right there. That's going to be what the graph looks like. The graph does not go into the positive y values at all. Okay? It does stay completely in the negatives. Its amplitude is only 1. So it's not a very tall graph. You could certainly do something with the scale to make it look a little different. But it is going to not be a very big graph vertically, okay? Because the amplitude is only 1. Alright, so that's what that graph's going to look like. So again, we located that axis first. Then we use the b value to make our period, which was just pi. And then we located the quarter point. 1/4 of pi is pi over 4. We located the half point. Half of pi is pi over 2. We located the 3/4 point. 3/4 of pi is 3 pi over 4. Okay? Now it's very easy to find out what 1/4, 1/2, and 3/4 of 1 pi is. A little bit more tricky when the period is 3 pi. Or the period might be, I don't know, like the period might be something like 3 pi over 4 or something goofy like that. If it appears 3 pi over 4, and you're trying to find 1/4 or 3/4 of that, then it becomes a little bit spicier. Okay? But this one, not so bad. Now, let's look at this one here. We've got 2 sine bracket 2x minus pi minus 3. Lots going on here. We've got that 2 inside the bracket here. Here's what we have to do. The very first thing we have to do is take a common factor. So it's going to be y equals 2 sine bracket 2x minus pi over 2 minus 3. And this right here is our c value. Okay? So we've got a lot going on here. We got an a value, we got a b value, we got a c value, and we got a d value that are different than the norm. They're all going to have an influence on the graph here. Okay? Big time. So what we're going to do though is we're going to focus in on that d value first. So the vertical scale can just be -6 to 6, which isn't bad. Okay? Okay, that's easy enough, right? So now, the rest of it's a little bit trickier, though. It is a little trickier, but we'll deal with that when we need to deal with that. The d value is -3, so we can go ahead and make our axis at -3. So here I go. Here's my axis at -3, all right? Now, the period, well, the b value is 2 again. And we just did a question where the b value is 2. And when the b value is 2, we divide 2 pi by 2, and we get pi. So the period of this graph is pi. So if the period of this graph is pi, then that's what we need to understand, because we'll go ahead and make our graph based on that. Okay? So I'm going to go ahead and make my scale here. I'm going to put pi here. And since we just did this, it's not going to be as difficult. Or at least it shouldn't be. There we go. There's our x scale there. Okay? So far, so good. Okay? Now, here's the interesting part. Okay? Normally, we'd be starting on the vertical axis, right? But we have a shift of pi over 2 to the right. Pi over 2 to the right. Okay? So, in other words, instead of starting on the axis right here, okay, where I've got that red dot, we have been translated pi over 2 to the right. Okay? So if we're being translated pi over 2 to the right, that means that we're really starting right here. Now, when we start on the axis, our next step is we go up to our maximum. The amplitude is 2, so our maximum will be right here. Then we'll come down, not to our minimum, but we'll come right down to our axis right here. So the real question is, how do we do the back half of this graph? Well, if we follow the convention of the sine curve, and the fact that the sine curve is continuous, in other words, it's one period, then another period, another period, then we should know that it'll go down to the minimum here and hit the axis right here. So it does start on the axis, but instead of going up, it'll start by going down based on that horizontal translation of pi over 2 to the right. Now, pi over 2 in this particular question represents half the period. So the graph gets shifted half a period to the right. And that is a really, really awful graph right there. So let me try and repair that so at least looks somewhat respectable. No, I think this thing is off kilter here. It is off alignment here, but I'm going to try and... There we go. Okay, there's what that graph is going to look like. Okay, so we've got the A2, the amplitude of 2, so the graph goes 2 units above and below that dotted axis line for the vertical axis. We've got the B2 that shortens the period to pi instead of 2 pi. We've got that pi over 2, which shifts the graph pi over 2 units to the right, or half of this period to the right. And we have the -3, which gives us that vertical starting point, or the vertical middle of the graph, being at -3. So again, understand the order here. We started with D, then we considered A to help us come up with a vertical scale, but instead of actually doing anything quite yet, then what we did is we considered what the period was, and we wrote in the scale there. And then we had to use the idea of that horizontal shift to start placing our points. Okay? So that's why we went over those curves, those sine, those cosine curves at the beginning of class. Because I wanted to make sure that you understood what those curves mean. Because if you truly understand that those sine curves and cosine curves are really basically 5 key points.
Good morning, everyone. It is 18 minutes after 9. You need to get up and over to school. You have just over 10 minutes to get to class on time.
Divided into quarters, then you can apply that to a graph like this without too much difficulty. Okay? Now, we still got 2 more to do here. Graph at least one period of this graph here. So what's this going to become? What's this going to become here? Well, we got to take that half out as a common factor. So that's y equals 10 sine. We got a half here. We got x minus 3 pi plus 3. Okay? So that tells us a fair bit, actually. Okay, it tells us that, tells us a fair bit. So let's go ahead and do it. All right, let's go ahead and do it here. Start off with D. We know D is 3, but we also know the amplitude is going to be 10. So we're going to need to adjust our scale a bit here. So what I'm actually going to do here is I'm actually going to go 0, 6, 12, 18, and I'm going to go -6, -12, and -18. And our D value is positive 3, all right? So I'm going to go ahead and put that positive 3. Okay, there's my D value there, okay? Now, I also see that I've got that half that represents the period. Now, 2 pi divided by a half is going to be our period. So 2 pi divided by a half is 4 pi, okay? 4 pi. So that means that I'm going to have a period of 4 pi here. This will be 3 pi, the 3/4 point. The halfway point will be 2 pi. And the quarter point will, of course, be pi. Okay? That's what I know. What else do I know? Okay? Well, I know that this is a sine curve, and normally it would start right here. But because of the horizontal shift of 3 pi to the right, it'll be starting right here. So, of course, the next point after the axis point is it goes up to the maximum. Now, the maximum will be, the amplitude is 10, so we're going to add 10 onto 3 and get 13. So the axis will be right about, or rather the maximum will be right about there. That'll be where the maximum lives, okay? Now, if we work backwards, At 2 pi, it's going to be down to its minimum. So that's going to go 3 minus 10 is negative 7. And at pi, it'll be back on the axis. And at 0, it'll be at its maximum. So we're going to go ahead and graph this sine curve. And we get this. Does that look familiar? Well, it should, because that looks, disregarding x values, disregarding y values, just looking at the shape, that's a carbon copy of a cosine curve. So what I was trying to tell you guys before was if we shift this sine curve or cosine curve the other certain amount, what we'll actually get is we'll get the other one. So what we see here is in this special situation, when we shift this thing the way we do, and we just look at 0 to 4 pi, we're actually seeing what looks like the cosine curve, but it's not. It's a sine curve. Okay? So again, we started off with D, our vertical axis. Then we found the period was 4 pi. We considered the A value as well. Using the A value and knowing that we had a 4 pi period, we were able to fill out the X and Y axis. Then, using the vertical shift, we started plotting points. We knew we started at 3 pi. At 4 pi, we went up to our maximum, and then we worked backwards. At 2 pi, we were at our minimum. At pi, we were back on the axis. And at the beginning, we were back up at our max. Okay? So that's what that graph looks like. Okay? All right. Okay. One more to go here. Graph one period of this. So this is already factored out for us. We don't have to do that part. But what's kind of interesting is we get this right here. Okay? That right there. So we see that D is negative 110. We see that Y is 250. So the Y value can go down as far as negative 360. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to make these words 40. So that's 80, 160, 240, 320, 400, negative 80, negative 160, negative 240, negative 320, and negative 400. And as far as the X scale goes, we'll get there in a minute, okay? But I guess we can draw on the axis line, because we know the axis line is negative 110. So if we go ahead and do that, negative 110 would be around, not perfectly, I got to actually move it because it looks like it's negative 120. It's not. Come on. Come on. Okay. It's going to be difficult, so we'll just do it again. Okay? We'll do it again. Alright, good enough. Okay? Good enough. Okay, so what I got to say is, what's that 2 pi over 60 mean? Well, if I take my period and I divide it by B, which is 2 pi over 60, well, 2 pi divided by 2 pi over 60 is just going to give me 60. So that's my period, is 60. Nothing in terms of pi, but just plain old 60. So 60 is going to be way over here. This is going to be 60. And that means that that's 30. That's 15. That's 45. Okay? Now, we got to keep in mind what that means. Okay? What that means is we're shifting 15 units to the left. Now that's interesting. 15 units to the left. So far all we've done is shift to the right. Shifting to the right is pretty easy. Okay? Shifting to the right is easy. But shifting to the left is a little bit trickier to kind of keep our eye on here. Because what that basically means is we take it and we shift it to the left. So we have to be aware of what would be at 15. And we have to shift it to the 0. Okay? That's what we have to do here. So if we're going to take what's at 15 and shift it over to the 0, we have to think of what this graph looks like. And all I'm going to consider right now is a scale. That's it. I'm not going to consider D. I'm not going to consider A. I'm just going to consider what the period is. Okay? This is a sine curve. Sine curve goes like this. Okay? That would be at 60, 45, 30, and 15. So what we see that's at 15 is the max. So the max gets shifted 15 to the left. So the max, which is at 15, gets shifted to 0. So in other words, like the last graph, we're going to start at the max. Now the max is the D value, negative 110, plus the A value, that's 250. So we get 140. So that's where we're going to start the graph, is at 140. At 15, we'll go to the next point. So if we look at this, the next point after the max is right back on the axis. So we're going to go right back on the axis at 15, which means at 30 we're at the minimum, which is negative 360. At 45 we're back on the axis, and at 60 we're back up at the max. So we're right here. So the graph, like the last one, is going to mimic a cosine curve based on the horizontal translation that takes place. And I'm not really satisfied with what this graph looks like. So what I'm going to do is I'm going to fix it. I really should have oriented the smartboard before I did this lesson. However, we still made it. Okay? That's what one period of that graph is going to look like. Okay? Right there. Beautiful. Okay? So again, we start off with D. We use A and B to help us shape the vertical and horizontal axis. And then we use C to figure out where each of those 5 key points are going to live. Okay? And just like anything else, practice is going to be your best friend when it comes to graphing these sinusoidal functions. Now we do have a work period scheduled for the next period. And given the complexity of these problems, I suggest that we keep that work period, okay? And I should be in class tomorrow, or next period rather. So I think it'd be a great idea to
Good morning, everybody. About a minute to get in class, so let's get moving and get into our classroom.